All right, so in the last video, I talked about how to set up a small signal test bench for your op amp. Now I want to talk about how to set up an output signal swing test bench. So there are several ways you can kind of do this. Some of them get pretty complex. So I'm just going to show you guys how to do the pretty simple, straightforward way. So I'm going to create a new cell view, and we'll call this op amp output sig swing TB. And I'm going to make this a schematic. Okay. And what I'm going to do is copy over my op amp and output load from my other test bench, as well as the sources. Okay. So for testing the output signal swing, we're going to put the op amp in feedback. And so I'm going to use an inverting amplifier configuration. And I'm going to create some input sources using, I'm going to first use this VDC source. And I'm going to set up one that goes to my non-inverting input. And I'm going to set up one, I'll just move these to be even. I'll set up one that will be for the inverting input. So I'm going to connect these up and connect them to ground. And I want to set these, so this is going to set your common mode input voltage. Because we designed for a common mode input voltage of 0 volts, I'm going to give it 0 volts. But according to the specifications for your lab, you can move this around to find the best point for your op amp that gives you the most signal swing. So you might want to play around with this value, but start with 0. Next, I'm going to use a V sine. This will give me a sine wave. And so I'm going to go down and I'm going to name the, let's see, it's going to be, there we go. In amplitude, I'm going to give it amp. So I'm going to make this a variable. And then for frequency, I want it to be, I think quite a bit lower than my bandwidth of the op amp. So I'm just going to do 1 kilohertz. That's nice and low. So let's see, where is it? I don't know that you actually really need to be much lower than the bandwidth, but might as well. Okay, so frequency is going to be 1 kilohertz. And I'm going to place that here, connect it to this guy, and then that's going to connect to the inverting input. Well, actually, wait, no, not straight to the inverting input. First, I need my resistors. So then I'm going to create my feedback network using resistors. I'm going to give this a gain of 10. The reason that we give it a gain of 10 is we want to make sure that what we're seeing at our output, the nonlinearities, is not due to our input being outside of the common mode input range. So we just give it a gain of 10 to make sure we're kind of safely there. And we also want to use a pretty large resistance in the hundreds of kiloohms to mega ohms. And this is because the op amp that we designed in this lab has a very high output impedance. And so if we use feedback resistors that are small, we'll see a lot of voltage division occurring where much of the output voltage of our op amp basically is being, like much of the voltage will be across the output resistance of the op amp instead of across our load resistor. And we'll effectively see a much lower gain. If you're confused about what I mean by this, we can talk about it in lab, or I can make something about it. So I'm going to use 10 mega ohms. Don't give it a length. That was my bad. I'm going to put that here. And then I'll make another one here, except I'm going to change this to be 1 mega ohm to give me my inverting gain of 10. And you can just connect this up like normal. And then check and save. Now the test bench is put together. So now let's create an Explorer or a Maestro view. And I'm going to, in my design variables, click on this, click to add variable, copy from. This is going to be my amplitude. And then in analysis, I'm going to use a transient analysis, and I want to simulate for 2 periods of my 1 kilohertz input. So that would mean 1 kilohertz is a period of 1 millisecond. So I would do 2 milliseconds. You don't need to set this, but I'm going to set it conservative just to be on the safe side. Okay. And then for my outputs, I want to plot the output. So you can do like outputs to be plotted, select a design, or I'm just going to add an expression and call it, or just get the output using this. Now I'll just name this out. Okay. And now this amplitude, what we want to do is we're going to test different amplitudes and see at which input amplitude we start to see distortion at our output. And that'll help us figure out how large of an output we can have before we start seeing distortion. So I'll do, let's see, our total supply voltage is 2.6 volts. So maybe I'll do 0.5 space 1 space 1.5 space 2 space 2.5. We'll try 1, 2, 3, 4, 5 of these. Go ahead and run my simulation. It's going to take possibly a couple minutes here. Hopefully not that long, so feel free to skip ahead if you want. Okay. What the heck? Oh wait, I made my inputs. Okay. Okay, my mistake. I made my inputs too big. Because if I'm multiplying by 10, then 0.5 would be an output of 5 volts. So this needs to be 0.05 and 0.1 and 0.15. We all do stupid things sometimes. And 0.2 and 0.25. Okay, that'll give me an output of ideally 0.5 volts, 1 volt, 1.5 volts, 2 volts, and 2.5 volts. Okay, and now we run again. Sorry for the delay. Once again, please just skip ahead until you see the waveforms show up. Okay, so now we have nicer waveforms. And if we look at this, we see this is the output of 0.5 volts peak to peak, and then we start to go up. And if we look at this, we see we have I think a pretty nice looking sinusoid here. Let's see, is it 0.5 volts peak to peak? Yep, just about. So it's pretty good looking sinusoid. But we can see when we get up to the 1 volt peak to peak, we see this starts to become kind of distorted. It doesn't look as much like a nice sinusoid. It becomes more distorted, more distorted, more distorted. On the lower end, we can see it gets so distorted that it just starts like clipping basically. So what we're basically looking for here is we're looking for the maximum peak to peak amplitude sinusoid that we can input that doesn't become distorted. So we can obviously see that these ones are too big. This one I think is just fine. So I wanted to be more sure I could run another simulation with some more values. So I could do a couple of values that are a little bit smaller, a couple that are just a little bit bigger, and just look for that point that when I start to see distortion, and that'll be about my maximum output signal swing. But from looking at this, I feel like I have a nice sinusoid here, and it's got a peak-to-peak voltage of a little over 0.5 volts. So I'm confident saying that my op amp has at least 0.5 volts peak to peak output signal swing, and that means that I've met the requirements of lab 2. And so I would call this good enough. And yeah, so that's how you can measure. That's a quick way to simulate output signal swing. And that's all I've got. All right, thank you.